For reactions in aqueous solution, as a matter of convention, the delta H formation of H plus is defined to be 0. Okay. Now, why do we have to make an arbitrary value for H plus? The reason is you cannot form ions individually in solution. They always come in pairs. So if you get the delta H formation of HCl aqueous, this is really H plus aqueous plus chloride aqueous. Okay, you can measure that delta H for that. That's, let's say it's X. Okay, since that would be the delta H formation of H plus ions and chloride ions. Okay, but they always come as, you cannot just have positive ions. They always come with negative ions with them. So as a matter of convention, for us to be able to tabulate a delta H formation for individual ions, we assign a value of 0 for H plus. So in this case, if delta H formation of H plus is 0, what's the delta H formation of chloride? Here you're forming H plus and chloride from the elements in their standard states. Okay? So what does this mean? Delta H formation of chloride, in this case, would just be equal to whatever that X is, right? Because here, you can say delta H formation of H plus and chloride together is X. But as a matter of convention, we're going to assign this a value of 0. So delta H formation of chloride there, then in aqueous solution, is the same thing as the delta H formation of HCl in aqueous solution. Here you have sodium chloride, okay? Aqueous solution. You're forming it from sodium solid, that's sodium in its standard state, so that's element sodium in its standard state. Cl2 gas is chlorine, the element in its standard state. You're making sodium chloride aqueous from sodium and chlorine in their standard state, so this delta H here would be Y. The Y that you have here, based on this information right here, you can say that the delta H formation of sodium plus the delta H formation of chloride must be equal to Y. Okay? So when you're dealing with aqueous solutions, the delta H formation of a salt in aqueous solution is just the sum of the delta H formation of the ions. So based on that, what would be the delta H formation of sodium then? This is going to be equal to 1. We already identified this as X, right? So delta H formation of sodium is equal to Y minus X. This illustrates how you can construct a table of delta H formation for the ions. And the value of being able to construct this table, so you now have this table that has all the delta H formation for the ions, is if you have a salt in aqueous solution, all you have to do is add up the delta H formation of the ions that you can look up. Okay? So let's look at this one. What is this first one right here? This tells you that the delta H formation of, you're forming HCl from its elements, right? So that's the delta H formation of H plus delta H formation of chloride is equal to X. What does this second one tell you? You're forming magnesium chloride in aqueous solution from magnesium, the element, and chlorine, the element. So that would be, the second equation says, delta H formation of magnesium ions plus 2 times the delta H formation of chloride ions, Y2, because magnesium chloride in aqueous solution is 1 magnesium and 2 chloride ions, right? So that must be equal to Y in this, if the delta H for this reaction is Y. Can I solve for the delta H formation of magnesium in terms of X and Y? What would it be? Is it A, B, or C? Remember we said, what is this one? H plus is 0. Can I solve for delta H formation of magnesium based on this information? Ready? What does this tell you? X is just equal to delta H formation of chlorine, so where would you plug the X? Right there. So this thing is just X. So what's the delta H formation of magnesium? It's just equal to Y minus 2X. Okay? So you can say here that that's delta H formation of magnesium ions in aqueous solution plus 2X is equal to Y. So you subtract 2X from both sides. So it's Y minus 2X. Yeah.